Okay, so this is a quick video to show you how to do some regression in Desmos. So just to recap a tiny bit of what we've done this semester, we've learned about various types of polynomials. So we started with linear functions, which are really degree 1 polynomials, or degree 0 in the case of our horizontal functions, y equals 5. So something like this. That's a nice constant function. We can make it a linear function. That's degree 1 polynomial. We learned about quadratics, which looks something like that, or even like this. We learned about polynomials of degree 3 and higher. Something like that. Degree 4, if we like, and so on. And then we just started our foray into exponentials. So things that look like this, or like that, or reflected over the x-axis, like so. And this week we're going to start looking into logarithmic functions, which have shape like this, and are the inverses to exponential functions. Remember, inverses mean that they're reflections over the line y equals x, and we'll get into the nuances of that some more as a reminder. So why does any of this matter? One of the things that we're going to look at is how to use our knowledge of functions to help model some real-world data. So for this example, I'm going to look at life expectancy by decade from 1900 till 2010. This data is from the Centers for Disease Control from 2013. So in the table, due to advances in medicine and higher standards of living, life expectancy has been increasing in most developed countries since the beginning of the 20th century. The table shows the average life expectancies in years of Americans from 1900 to 2010. Here we're being asked to let x represent the time in decades starting with x equals 1 for 1900, x equals 2 for 1910, and so on until we get to x equals 12 for 2010 here. So as you can see, the x is going to represent our years or our independent variable, and the y will represent our life expectancy in years. So what I've done is I've gone to Desmos, I've clicked the plus sign, and I've entered table mode, and I put in 1 through 12 for my x's. In fact, Desmos gets really good about realizing what my scale is, and I just start to press enter, which is kind of cool. And then in the y column, I'm putting in the average life expectancy, and so on. Okay, so I've already done that here, and you notice that it gives the automatic subscript 1 to the x and the y. That's going to be important in a moment. If we zoom out, we should be able to see a beautiful little scatter plot of our data points. Now, this could look like it might fit a line here to predict our data, but now that we have some more models under our belt, you can see that actually a logarithm might be better here. So logarithmic regressions are mostly used for phenomena that grow quickly at first and then slow down over time. But the growth continues to increase without bound. Now, of course, humans cannot live forever, so this part doesn't make complete sense, but you will see that the log model will fit nicely. So how do you do this? So you're going to put in a new line, y sub 1, so y, and then for sub, I use the key next to my 0, shift, and then minus sign. And then I put this tilde, which is on the left side of my keyboard, then a ln x sub 1, and then plus b. This might take you, a minute or two to figure out how to type in. Okay, I'm going to select log mode here. And then what this is telling me is how strong the correlation is. So it looks like it's a pretty strong correlation. That's not a causation, right? Just means that the two variables, year and life expectancy, are related. And then what's really cool is they even tell me what the model is going to be. So here the A and B values are the things that I can now substitute into this model to predict life expectancy for, let's say, 2030. So our model is as follows. We can say y equals, or f of x equals 13.8575, I'm stealing that right from here, where the parameters are, ln x, plus the b, which is the 42.5272. So I get this equation that I can now use, again, to figure out some other year's life expectancy. So for 2030, right, what is my x going to be? Remember, x equals 12 was our 2010 year. So if x equals 12 for 2010, and we're going by decades, x equals 13 will be 2020, x equals 14 will be 2030. So we need to take x equal 14 and substitute it into here. I'm going to copy and paste. I'm going to put 14 in here, and I get a life expectancy of 79.1 approximately. Does that make sense with the data? Seems like it. As the decades go by, our life expectancy increases, but it starts to increase kind of slowly. And so there's not a huge difference from 2010 to 2030, 20 years later. Okay, that's your primer on regression. Let's do this.